All right, so we're going to move to what's called the product rule for logarithmic functions. So with this rule, we're going to start by remembering the exponent version of the product rule, right? We've reminded you about this before, I think, but hopefully you remember if I have a base to a power times the same base to a different power, we just add the powers, right? B to the m plus n. That's our exponent power rule, right? So the log version here will be basically the same. It's not the same thing, right? If we have it kind of is. If we have the log of a product, right? We have a product here, m times n. That is going to be the sum of the log of m plus the log of n. And this is true, of course, for log base b, natural log, common log, whatever. This is a very important log rule. You're going to use it if you go on beyond college algebra, if you go on into calculus, you're going to need to remember this one, okay? So it's got a fairly easy proof. I'm not going to ask you it on the test, but let's say we let log base b of m be x and log base b of n be y, all right? Then m times n, well, let's just say, let's write it this way. Log b to the x would be m, and b to the y would be n, right? And so m times n would be b to the x times b to the y. So far, so good, hopefully, right? And so, of course, we know that. We can say, oh, well, that b to the x times b to the y is b to the x plus y, right? So that's m, n. And then we can rewrite that as a logarithm, right? We can say, oh, log base b of mn is equal to x plus y. And then we say, but oh, wait, x was log base b of m, and y was log base b of n. So there we go. We've got our property here, our rule. Okay. So we'll do a couple of examples with this. So if we have log base 2 of x of 8 times 64, we don't want to multiply 8 times 64 and then figure out the log, especially if we're stuck on a desert island with no calculator, right, or computer. So we're going to say, okay, great, I have a product here, a log of a product. So I'm going to say, okay, this is log base 2 of 8 plus log base 2 of 64. And those I can kind of figure out, right? 2 to what power equals 8? Well, that's 2 to the third. And 2 to what power equals 64? Well, I'm going to go 2, 4, 8, 16, 32, 64. That is the 6th power of 2. So this is going to equal 9. All right. So what about log base 2 of 16m? So same story. This is a product, right? So we can break it down, log base 2 of 16 plus log base 2 of m. Now we can do a little bit with this because log base 2 of 16 is going to be 4, right? But we can't do anything with log base 2 of m, so that's going to be the end of the line for that one. What about log of 0.2x? So we're going to say, oh, look, we got a product again, right? So I got log of 0.2 plus log of x, and this is common log, right? Now here, this one's kind of got a little bit of a hidden product. So I'm going to say, but wait a second, log of 0.2 is 2 times 1/10, right? And so now I have another product here. So I can say, oh yeah, well that's log 2 plus log of 1/10, and then plus the log of x. And the log of 1/10 we can actually change into a number. So log of 2, that's, I'd have to use my calculator to figure out that number. It's not nice and pretty, but log of 1/10, in fact, I'm going to leave this. Log of 1/10 is going to be -1, right? 10 to what power is 1/10? It's to the -1. And then usually we'll put our logs first, but it's not a big deal if you don't. All right, and then we have one that's really just the definition of the rule, ln of AB, we're going to say, oh yeah, that's ln of A plus ln of B, right? Now, please, please, please remember, this does not work over addition. We can do nothing to simplify ln of A plus B, okay? We cannot simplify this one, okay, because it's not a product, it's a sum. Okay, so this is a good place to break, and we will talk about our next rule in the next video.